So today we're going to solve radical equations. In our first example, you'll notice we have x squared equaling 9. The only way to undo a squared term is to square root it. And if you remember, when we square root both sides of an equation, we have to take a plus or minus value of the square root of the other side. So the square root of x squared is x, and that's going to be equal to plus or minus the square root of 9, which is plus or minus 3. As we also know, this can also be done by setting it equal to 0 and factoring in this case, but this is the rare case where a problem like this can be done using factoring. But in either case, you've seen it. So we have plus or minus 3. Now, likewise, if we have a square root, the only way to undo a square root is to square both sides. So if I square 4 and square x squared, we end up with 16 equals x. And this is a style of equation we're mostly going to be working with today. So this is really no different than the problem we just did, except for the fact that what's under the radical sign is more than just a variable, it's an expression. But in either case, if I square both sides, any root multiplied by itself is just what's under that root. So the square root of 2x plus 1 squared is just 2x plus 1, and then 7 squared is 49. Add the, or subtract the 1, sorry. Get 48 is equal to 2x, and then x is equal to 24. We can check this real quick by saying that's 48 plus 1 is 49, and the square root of 49 is 7, so it checks. This is similar, except the fact that on the left side of the equation we have a variable instead of a constant term. So I'm going to approach this the same way, square both sides, end up with x squared equals 7x minus 12, and the only way to solve this quadratic is to factor. So I'll set aside equal to 0 and say what multiplies to 12 and gets me 7. It's looking like x minus 4, x minus 3 equals 0, so we end up with 3 and 4 as our two solutions. And remember, if this didn't factor, we could still use a quadratic formula. Now in this case we have a binomial expression by itself, and this radical we can again square both sides, except we'll have to FOIL the term on the left. So we end up with x squared plus 6x plus 9 is equal to 2x squared plus 17. Again, set aside equal to 0. I like keeping my squared terms positive, so I'll bring all these terms over to the right. So I have 0 is equal to x squared minus 6x. 17 minus 9 is 8. What multiplies to 8 adds to negative 6. That's negative 4 and negative 2. So I end up with 2 and 4 as my solutions. Just checking the answers once again. We've got a total of 8 and 17 is 25, and that's equal to 5 when I square root it. And then I have 16, 32, 49, and the square root of 49 is 7, which checks as well. So you'll notice in this example that the square root term is not isolated. In all of our other examples, this radical term was by itself on one side of the equation. So that's the first thing we're going to do on all of these, is make sure that the root term is isolated. So what we'll do is we'll add an x to both sides of the equation, thus giving me the square root of 9x plus 9 is equal to x plus 1. And just like our previous example, we'll now square both sides of the equation, making sure we FOIL the term on the right hand side. So this gives us x squared plus 2x plus 1. Set aside equal to 0, x squared minus 7x minus 8 multiplies to 8, adds to negative 7, to negative 8 and a positive 1. So we end up with 8 and negative 1 as our solutions. Very similar example here. We have to isolate our radical, so I'm going to bring the 3 over to the other side, thus giving me 3x plus 3 is equal to root 7 minus x, and then I'll square both sides. FOIL this side out, that gives me a 9x squared plus 18x plus 9 is equal to 7 minus x. Again, set aside equal to 0, that's 9x squared plus 19x plus 2 is equal to 0. I'm going to use a 5-step here, so this goes to x squared plus 19x plus 18. What multiplies to 18 gets me 19. That's x plus 18, x plus 1. Remember, it's a 5-step, so divide by 9, reduce, and remember this is still set equal to 0. So then solve these two equations. We end up with x equaling a negative 2 and x equaling negative 1/9. The negatives kind of scare me a little bit. I'm going to check these answers. We end up with a negative 6 equals the square root of 9 minus 3. This ends up being 3 minus 3 equals negative 6. So that term actually doesn't work. The negative 2 is an extraneous answer. If I plug in 1/9 of the negative type, I end up with negative 1/3 equals 7 and 1/9 all square rooted minus 3. 7 and 1/9 is 63. 64 over 9 minus 3. This ends up being 8/9, or 8/3, I'm sorry, minus 3, which is equal to 2 2/3 minus 3, or negative 1/3. That actually works. So my answer in this case is just negative 1/9. This example is a little bit different in that we have two radicals, so I can't really isolate one radical, but what I tend to do is I'll isolate the most difficult radical. So this has the most stuff in it, so I term that as the most difficult radical. I'm going to bring this radical to the other side. So what I have is I have the root of x minus 5 equals 5 minus root x. Now the only way to undo this radical is to square both sides. Well, in this case, that's great. That's going to get this x minus 5 out of that radical, but in this case I have to FOIL this term. So I'll have to multiply this by itself. Harder to do visually, so I'm going to write the whole thing out. We have 25 minus 5 root x minus 5 root x plus root x times root x, it's just root x squared, which is x. So you'll notice that even though I squared both sides, I don't get rid of all of my radical terms. I have 10 root x here plus x. Now what I can do is I can again try to isolate my root. So I'll do that, bring the x over and the x's go, bring the 25 over and I have negative 30 equals negative 10 root x, which is kind of nice because I can isolate that root again, and I have 3 equals root x, so x is equal to 9, and that's after squaring both sides. This problem is even more complicated because both roots are pretty difficult. Since I have more of a coefficient term in front of this x here, I'm going to dictate this to be my most difficult radical. So I have 2x minus 2 equaling 1 minus root x plus 6. Again, we'll take and square both sides, which means multiplying this term on the right by itself. So I have 2x minus 2 equaling 1 minus root x plus 6 minus root x plus 6 minus, actually I'm sorry, that's a plus, root x plus 6 times root x plus 6, both are going to be just x plus 6. Combine like terms, I have x plus 7 minus 2 roots of x plus 6 is equal to 2x minus 2. I'm going to get rid of these terms here, bring the x over, have x, bring the 7 over, minus 9 is equal to negative 2 roots of x plus 6. I could divide by negative 2, but then I bring fractions into the problem. In this case, I can't totally isolate that radical, but this is close enough. I'm going to square both sides again because I do want to get rid of that radical. Now, you'll notice on the left side I have a subtraction problem. On the right side, this is a multiplication problem. Where I have this binomial, I'm going to have to FOIL. I have x squared minus 18x plus 81. Now in this term, since it's a multiplication, I can multiply negative 2 by negative 2, because again that's just negative 2 root x plus 6, and we multiply our numbers by our numbers and our roots by our roots. So this goes to 4 times x plus 6, because that root multiplied by itself just pops out of the root. I can distribute. When I do so, I get 4x plus 24. Set aside equal to 0. That's x squared minus 22x plus 57. Hopefully that factors. What multiplies to positive 57 adds to negative 22. That's x minus 3, x minus 19, set equal to 0. So again, I have 19 and 3 as my two answers. We can go ahead and check this one. That's what, 58 minus 2. I lied. That's 38 minus 2 plus 25 is 1. This isn't going to work because this goes to 6 and 5, which is 11, should equal 1, and 19 is no good. Let's plug in 3, and we get 6 minus 2 and 3 plus 6 is equal to 1 again. And in this case, this goes to 2 plus 3. That's disappointing. That doesn't work either. So this has no solution. But the process was good. So we move to a problem similar to what we did the other day, in that we have a rational exponent. We're going to raise both sides to the reciprocal power. So this is to the 3/2 power, and this is to the 3/2 power. And this is going to create a little complication. I'll tell you why in a minute. When I raise the power to a power, I multiply powers. And you'll notice that since my denominator is a 2, I'm actually square rooting a side, which means I have to have a plus minus answer. And I'll show you that by doing this problem another way in a second. So this is 2x minus 3 is equal to plus or minus square root of 25 cubed. So I have 2x minus 3 is equal to plus or minus square root of 25 is 5 cubed, which is 125. So when I take 3 plus 125 and then divide that by 2, that gives me an x. So in this case, this is 128 over 2, which is 64. And then when I have x equals 3 minus 125 over 2, that gives me a negative 122 over 2, or x equals negative 61. So I said I'd show you why we need that plus or minus. If I chose to write this in radical form from the beginning, that's the cube root of 2x minus 3 squared is equal to 25. So if I want to get rid of that squared term, I'd have to square root both sides, and when I square root both sides, we've got to take the plus or minus. So there's where that comes in. I still have a cube root here. 2x minus 3 equals plus or minus 5. Then I cube both sides, and you'll notice now that I have the same part of the equation as I did in the other problem. That's all we've got today. Fill out your lesson summary, do your My Math Lab. See you tomorrow.